Dear aspirants, welcome to my channel. This is the remaining questions, model question paper 2, concepts of electrical circuit. Subject code is 25E 21I. So this is the fourth question, state and prove Kirchhoff law with a simple resistive network. Okay. So first in that Kirchhoff current law, KCL. So what do you mean by, what is the statement of that? Algebraic sum of the current at a junction is 0. So total incoming current which will be equal to total outgoing current. So this is the diagram which will be represent Kirchhoff current law. So total incoming current will be equal to total outgoing current. This is the junction point. Okay, this will be the junction point of. Just I am going to explain about above diagram. Consider a junction where current I1, I2 and enter. I3 and I4 we are not represent. I4 is leaving, but conservation charge cannot be accumulated in a one junction. Therefore you will get I1 I2 is equal to I3 and I4. This is Kirchhoff current law. Same way Kirchhoff voltage law. Coming to the statement, algebraic sum of all the voltages in a closed loop is 0. So sum of the voltage rises which will be equal to sum of the voltage drops. Coming to the Kirchhoff voltage law diagram. So this will be an Kirchhoff voltage law diagram. There is a resistor, current, voltage, resistor 2 and resistor 3. Now we are going to explain the point-wise explanation. Consider the closed loop containing source voltage V and resistor R. By conservation energy, surplus energy will be equal to consuming energy. Therefore, the equation V minus IR1, IR2 minus IR3 is equal to 0. The statements as explained in the single equation. So, more point, Kirchhoff current law based on conservation charges, Kirchhoff voltage law based on conservation energy. Next is Kirchhoff current law applies at the junction. Kirchhoff voltage law applies close the loop. Kirchhoff laws are widely used for circuit analysis. And next question is state and explain Fleming's right hand thumb rule. Fleming's right hand thumb rule. Coming to the statement, Fleming's right hand thumb rule used to determine the direction of induced EMF or current in a conductor moving in a magnetic field. Here, stretch the thumb, forefinger and the middle fingers of the right hand mutually perpendicular to each other. Here forefinger represent direction of magnetic field, that we call it as in capital B. Thumb is direction of motion of the conductor. Middle finger which is the direction of induced EMF current I. So this is the diagram, Fleming's right hand diagram. This is the diagram you can see here. So thumb which will be represent direction of motion of the conductor or moment, forefinger direction of magnetic field, middle finger direction of the current induced. So here north and south direction is a motion and induced current and magnetic field they are going to represent. Coming to an explanation. So use it for generator to find the direction of induced current, magnetic field motions and current is perpendicular to each other. The thumb indicate the motion of the conductor, forefinger shows the magnetic field direction and middle finger will give the direction of induced EMF, induced current. Next we will be explain the Faraday's law with the relevant examples. In the Faraday's law of magnetic induction, the first law, Faraday's first law statement, whenever magnetic flux linked with a conductor changes, an EMF induced in a conductor. So if the conductors in a closed circuit, induced current flow through it. Coming to the example is when a magnet moves towards the coil, current is induced in a coil. So coming to the Faraday's second law, The statement is the magnitude induced EMF directly proportional to the rate of change of magnetic flux linkage. Coming to the formula, this is the formula that represent the directly proportional to rate of change of magnetic flux linkage. Okay, where E nothing but EMF, induced EMF, N is the number of turns of the coil, phi will be an magnetic flux. So coming to an example, the fast movement of magnet produce large induced EMF. Changing magnetic flux is necessary for the induction. The more rate of flux changes will give the more induced EMF. The negative changes, negative signs represent Lenz's law. The Faradays are used for generators and transformers. Unit for the induced EMF is volt. Next is described RL series of circuit with a phase diagram and equation. So before going to that, what do you meant by RL circuit? So it RL circuit consists of R. This we call it as a resistor R and inductor L connected in a series of with a AC supply, that we call it as an RL circuit. So working principle, let us coming to the working principle. The same current flow through a resistor and inductor. The voltage across VR is the phase with a current. It is the phase with a, and the voltage across inductor VL that leads to a current in 90-degree. Supply voltage to phase some VL and VR or VL. Current lag behind the supply of the voltage. Coming to the circuit diagram and phase diagram. So this is the circuit diagram. So these are the equation. Okay. So inductive reactance and impedance, current, phase angle. So voltage across the resistor, okay, voltage across inductor, okay. Okay, supply voltage is a formula, power lagging, power factor lagging. So this is the phase diagram. This will be the phase diagram. Okay, this is the phase diagram with respect to VR and VL. So tan phi is equal to VL divided by VR, or is equal to XL divided by XL. So this is the phase diagram. You can write it in the exam. Next question, compare three phase supply with a single phase. What is the comparison? Coming to the single phase supply, as only one AC voltage waveform, it contains only one voltage waveform, and it is uses for two wire at phase or neutral. Power delivery is not continuous, suitable for domestic appliance and small loads. Efficiency is lower. Motors are less efficiency and need to start devices. Used for homes, shops and offices. Used for power loss. Here power loss is more. Single phase supply used for light loads, where the light loads will be there you can use. So coming to the three phase supply, here three AC voltage waveforms. Use 3 or 4 wires. Power delivery continuous and smooth. Efficiency is higher. Motors are self-starting and more efficiency. Used for factories and large industries. Power loss is very less. Three-phase supply used for heavy loads. If the content is useful, please subscribe my channel, share and support. So keep watching my videos. Thank you.